Okay, so now we move on to transfer learning and multitask learning. So in transfer learning, experience with one learning task help an agent learn better on another task. For example, a person who has already learned to play tennis will typically find it easier to learn related sports like racquetball or squash. A pilot who has learned to fly one type of airplane will very quickly learn to fly another type. Or a student who learned algebra will find it easier to learn calculus, and so on. So we don't know exactly how humans transfer learning from one field to another, but for neural networks, learning consists essentially of adjusting weights. So the best possible approach for transfer learning then is to copy over the weights learned from task A to a network that will be trained for another task B. The weights are then updated by gradient descent in the usual way using data for task B. That maybe even be a good idea to use a smaller learning rate in task B, since you don't want the weights to change too much. You're fine-tuning them essentially, depending on how similar the tasks are and how much data was used in task A. So note that this approach requires human expertise in selecting the tasks. For example, weights learned during algebra training may not be useful in a network intended for racquetball. Also, the idea of copying weights requires a simple mapping between the input space for the two tasks and essentially identical network architecture. So we can't change the network since we're tied to the starting weights that we got from the task A. So we can't really do anything. We can only add a layer at the end, for example, in order to map the output to a new space, or maybe an input layer to map the input from the new task, but nothing inside the network itself. Now, one reason for the popularity of transfer learning is the availability of high-quality pre-trained models that you can download and start using right away. For example, you could download a pre-trained visual object recognition model, such as ResNet 50, and this would save yourself weeks of work, because this already model is billions of parameters that has been trained on a huge data set to recognize objects in images. And all you have to do then is to fine-tune it to your specific task. So from that original model, you can modify the parameters by supplying additional images and object labels for your specific task. Suppose, for example, you want to classify types of unicycles, and you only have a few hundred pictures of different unicycles. But the original data set that was used to train the ResNet 50 model has over 3,000 images of bicycle, motorcycles, and skateboards. This means that the model ResNet 50 already has experience with objects with wheels and roads and other relevant features that will be helpful in identifying the unicycle images. When we use transfer learning, typically we freeze the first few layers of the pre-trained model, because these layers serve as feature detectors that will be useful for your new model. Your new data set will be allowed to modify the parameters of the higher levels only, so not the very first layers. These are the layers that identify problem-specific features and do classification. Another example, say for example you're building a natural language system. Typically now we start with a pre-trained model like Roberta, for example, which already knows a lot about the vocabulary and the syntax of everyday language. It's been trained on a huge corpus of text. And the next step is to fine-tune the models in two ways. First, by giving it examples of the specialized vocabulary used in the specific domain you're working on. Maybe you're working in the medical field or maybe financial field. And then next, by training the model on the task it's supposed to perform. For example, if it's eventually will be required to create new text or answer questions and so on. One very important kind of transfer learning involves the transfer between simulations and the real world. For example, the controller for a self-driving car can be trained on billions of miles of simulated driving, which would be impossible in the real world. You would never actually train a network on billions of real miles, right? That would take forever. Then, when the controller is transitioned to the real vehicle, it can then adapt quickly to the new environment because it was already pre-trained on such a huge data set. Multitask learning is a form of transfer learning as well, in which we simultaneously train a model on multiple objectives. For example, rather than training a natural language system on part of speech tagging and then transferring the learned weights to a new task such as document classification, we train one system simultaneously on part of speech tagging and document classification and language detection and word prediction and plagiarism detection and question answering. The idea is that to solve any one of these tasks, a model will be able to take advantage of this pretty much the same features in the data. But to solve all 8 at once with a common representation layer, the model is more likely to create a common representation then that reflects natural language usage and content. So this is the idea of mixing together multiple tasks like this and then force the model in a sense to find the most common representation of the input data. Okay, that concludes this week's lecture. See you in class.